Welcome to Tech Talk Live. It is Tuesday, April 21st, 9 p.m. in the DMV. I'm Sam Giacinto.
And 6 p.m. here in Los Angeles, I'm Jack Armstrong. Welcome to Tech Talk Live. Today, we're joined by a special guest, Alex Kihm, the founder of POMA AI, a tool that's tackling one of the most critical challenges in AI right now: how you break down, ingest, and chunk documents so AI systems can actually retrieve the information. If you've ever wondered why your AI agent might be giving you terrible answers, even though the data is right there, Alex is building a solution. Alex, welcome to the show.
Hi, thanks for having me.
Welcome. So this is a crucial problem because going into this, just thinking about paper as a historical piece of documentation. I mean, it's from the beginning of paper to the dawn of computers. That contains a lot of information. Everything that's been written down since the beginning up until the digital age. And in a lot of ways, really any non-tech startup, any entity which has existed beyond the internet has a filing cabinet full of paper they're interested in perhaps using in new ways. So it's like one of those things, for 99% of humanity, we did not even have digital records, and now it's probably 99.9 or something, some ridiculous percentage. But just that's really researching this episode. That's something that stuck out to me is the digital documents are relatively new, despite some of us having had them for our whole lives.
Yeah, true. And the funniest thing is, I mean, I would say, even if from what we see now, the, let's say, paper problem, it's a very big one and it's adjacent. But the craziest thing about it is that not the first, but also until today, digital documents are still produced like paper. So it doesn't even matter if you get a good scan or if you get like a digital native document, because funny enough, when people produce digital documents like your report PDF, it doesn't even matter that much if it's, in your filing cabinet or if it's a PDF, because basically, we still think in paper when producing even digital documents. This is why you have pages in PDF.
Mm.
And, going not to go too deep on the tech stack, but if you look into what PDF is, it's basically, PDF passes to PostScript, and PostScript is a printer language. So if you produce a digital document where you think, I see the table, I see all the information, everything relates in the image and whatnot, and I can click it and so on. No. In the end, it means, dear printer, please print a line here and then a line here and then a line here, and that makes a table. So you can print it out. So literally, paper we don't even need paper as a medium to think that we are still in the paper age in that case.
There's a lot of metadata hiding in the document that just tells you how to print it, I guess. And it's
Well,
funny because
not
something
only
clicked for me.
metadata, it's actually what it's actually how it's encoded. Like the
It's just
content is literally print this. Yes.
it's just actual. Yeah, there's so much actual data versus the percentage of data spent on the content versus the instructions for printing the content. It's probably 50-50, maybe even more,
Fair game.
I imagine. Um, but it jogged my memory because Google Docs has a pageless option now. Not to divert but that kind of clicked for me, where it's like even the concept of a page, right? A document has a page, even if you see it on the screen,
Exactly.
where the screen is not. It's infinite. It's of a dimension which usually has a ratio, but it's not. Everything is centered around an 8.5 by 11 sheet of paper. And that's all.
Yeah,
Even on
or
the
in the
laptop
page list,
screen.
feature, it's basically, the funny thing is they actually, that is inspired by a web page. So you just if you click on page list, it becomes HTML, so it becomes a page in the web sense of things. So which is also funny, right? We talk about home pages and web pages and stuff, or just the page are endless. So if a landing strip one pager, as you say, one pager could be one literal page memo or a one page website, which is like infinitely long. But that's like, we're still between HTML or PDF, and then both have pages, so to say. Just one page is infinitely long.
Huh.
Yeah.
That's kind
Well,
of
so
crazy to think about that. Huh.
yeah, so for people that aren't as familiar with this RAG retrieval,
Yeah,
in plain language, can you just kind of
yeah,
explain
absolutely,
what
absolutely,
POMA AI
absolutely.
and what's the problem it's really
Yeah.
solving?
Yes, yes. So the thing is, let's wind a bit back, like 2 years or something. The earlier days of ChatGPT and AI adoption for everyone. I mean, the GPTs exist for a bit more, but generally, let's say what we all saw, we were like blasted away. Wow, ChatGPT, your mother or all of a sudden writes like letters to you in Shakespearean style and whatnot. That's super funny. But whenever you asked it something factual, like there was this thing I asked it, okay, who is Alexander Kihm? Like, and there's actually very few people with my name, so you cannot really mix it up. And what it came up with was, I mean, it was, for the record, nothing of this is true, but it came up with like serial fraudster, somehow connected to internet business and whatnot. And like, what the fuck? Like, it totally made up stuff because it was just, I mean, well, it's not a stochastic parrot, but it learns a lot of texts and then abstracts away from that. And then people thought, okay, we can just train it more, feed it more text, feed it half of the archive of the New York Times, feed it whatnot, whatnot, whatnot. But it will always, I mean, there's this analogy of like pissing in the ocean, and you can have all of humanity piss in the ocean, and then still you cannot ask, exactly what one person ate or drank, and because it gets extracted away. So it has consumed all that, but it can never replicate an actual fact, which is, if the more they trained, the more intelligent the models became, and that is true. And it kind of topped out at GPT 4.5, which now is retracted actually, because it was like too much training data. And then they thought like, okay, damn, how do we get facts into this? Then came like the fine tuning phase where people were like, okay, let's try to, insert our data. So we have like the model that is built, and then we say we have our corporate data, all your filing, the stuff in your filing cabinets, you scan them, and you use fine tuning with this. And still, what happens? It happens that it starts talking like these documents. So if you put like a lot of, let's say, jury verdicts, then it starts talking like a like jury verdicts or a judge or whatnot. But that's for skills and style. Or if you have like some problem, okay, I cannot explain the problem to you, but I can show it to you, and you look at me, and then you learn how to do it. Abstract knowledge. Both is still, and that's the key concept, abstract. So now the problem is, if you have facts, facts are not abstract. Facts is like Berlin is sunny right now, um, and I mean right now. So the only thing you can say is the AI needs this information, and the only way they do it, and that's like super established. I mean, there's people who say RAG is dead, blah blah blah, but they don't mean that this concept is dead. What you need always is that the AI, as intelligent and fine-tuned as it is, needs to have some injected current information. It's a bit like a cheat sheet. So you say, okay, can you, with all your intelligence, all your education, all your background, answer me this question that you don't have the facts about, but here's a cheat sheet with the facts. And then you give like the most elaborate answer, but based on these facts. And providing these facts from the big library that's over there, that is what RAG does. So you feed it a library, you deliver all your books, all your information, all your stuff to a RAG, or we call it a context engine if it's more elaborate. And then when a question comes up, you go to the librarian, which is the RAG system, and the librarian produces how is it called? The Cliffs Notes for exactly that question. That's what RAG does.
Yeah, no, absolutely, because you're augmenting the generation but with the cheat sheet information.
Exactly.
Yeah,
Exactly.
so that it's
Well,
more
cheat sheet is how we
accurate.
call it, our special
No,
one,
for
but
sure.
let's say the Cliffs Notes. Yeah, the librarian's
Yeah,
Cliffs Notes.
yeah, absolutely. That's awesome. So yeah, so now with AI theoretically, so with POMA specifically,
Yeah,
can you walk through the workflow? So
absolutely.
if you're a developer or
Absolutely.
and you have a pile of documents, like what is POMA actually doing with them?
Yeah, yeah. So,
And how is it
like, go.
taking it like yeah, and how is it taking it to make more sense of it? Like
Yeah,
with Markdown or yeah, can you explain the process?
absolutely, absolutely. Sorry, by the way, I had a bit of latency. We're talking across the Atlantic for the listeners, so sometimes it seems like I just want to cut his word. No, this is latency, so I later get that his question still continues. So I'm sorry for that. Um, So yeah, the thing is, well, RAG or this whole process, as I established, as I said, is kind of well established. So what you do is you get all your documents and you put it into what is called ingestion. So there are tools, there are free tools, there are elaborate tools, there are a lot of paid engines and so on, because you have PDFs, like we said. Okay, it could be either a scan of what you have offline, or the native PDF that you have got via email, even your emails as well, like whatever stuff you have, like all of formats. A lot of PDF. Some also could be Excel, but let's stay with PDF for the sake of simplicity. So you need to get this PDF into AI. And now what people do, and you see that, for example, you open up ChatGPT and then you say, okay, I have this rental contract. Please analyze it for me. And now it mostly goes well. It's, by the way, because they secretly rag under the belly, but that's their trick. But if you put, like, let's say 500 pages of, I recently did this, there's always this official price list of, cell providers, and they always, because they want to hide their actual prices, they always put this 5,000 regulatory document where you then can chase your actual, plan. And then you ask, okay, what's the price for my plan? And it's funny how it's almost certainly will get it wrong because it's just too much information. The problem is that, if you AIs have context windows, it's like what people now hear a lot about because they're so big and now 1 million tokens and whatnot. Let's say one page is roughly 1,000 tokens. That's like the rule of thumb that everyone can, work with. So you would think it can actually digest 1,000 pages per, take, which is actually a lot. Like, let's say, I mean, that we have seen a lot of questions that actually need information that is on 1,000 pages. If you think of, on each page, there's just a bit that you need, but still it would be quite impressive for most tasks. Problem is, it's not exactly true. So there's like shortcuts involved. And if you go beyond, let's say, maximum 100 pages, it starts, being a bit like when you give to an inexperienced, like you have an assistant and the assistant doesn't have much time, you give it a 100-page manual, and then obviously he or she would say like, yeah, so it's about that, and then and at the end it's this and that. This is exactly what's called like lost in the middle, and you see this. So what you need to do is you need to bring it down to Cliff's notes. Like, it has to be concise, otherwise the AI gets lost. And this is where, you cannot have like the standalone, like, let's say ChatGPT, you upload a document, but you need some sort of auxiliary system that does this, what I always call the librarian. Like, you give it the question, it, produces something concise enough that is only the relevant parts and then gives it to AI. This is how, RAG works. And this is exactly where, the difficulty starts, because these systems, they exist for a long time. Like, they're quite straightforward. You have some sort of ingestion engine, and then some sort of, and now it gets interesting because we talked about only the relevant pieces. So a piece must obviously be chunked. You have like, what is it? You could be one page, or you just say until, I deem the piece full enough or whatnot. And the normal way of doing it is currently you either, just parse the document, let's say programmatically. Then you have a problem, for example, with images, because I mean, what do you do with an image? Then there's just image or something. So if you have like a cheap engine for ingestion, the first part of the problem, what lands in the chunking is already, And what we found out is that, for the ingestion, the first part, the language that AI speaks is Markdown. So AI consumes information in Markdown. For those who are not so familiar with it, if for example, you go to GitHub, whatever, repository you want to check out, and if it's open and then you just click edit on, the README page, then you see what Markdown is. It's GitHub. Markdown is a bit, special flavor, but you see there's hashes in front of, like, the number one headline has one hash, the lower ones have two hashes, and so on. You make things bold by putting asterisks around it. And then, stuff like that. That is like, or basically like some people format WhatsApp messages. That's also kind of Markdown-ish. So it's kind of human readable. But as you see, there's like these formatting and highlighting and heading instructions, and these are super valuable for AI. So in the ingestion step, the first thing you need to do is get the document somehow into a good Markdown format. That's the first step. Sounds simple. It's quite tough. You might involve scanning. You might involve, okay, what do I do with the images? Then there's tables, and tables should never be Markdown, but inline HTML, because Markdown, loses the spans and stuff. So that is the first thing that makes it so tough. But imagine you have the perfect Markdown. Then comes the thing, okay, how do I cut it up now? Because let's say you have this very simple example, and then, the long elevator ride pitch is over. So you have this document, and then you have in article 1, there is like, these elements are so important, a lot of pros, and then a lot of subheadings. And then down here is a table that just says, in its caption, prices. And then category A, 500, category B, 2000, and so on. And the problem is, now imagine the whole prose that explains what this whole thing is about is up here. And then in the meantime, you just, you decided, oh, my piece is full, and you cut. So this table doesn't know what it relates to, and this heading doesn't know that finally what the information is down in this table. And this is exactly what happens to, let's say, 99% literally of systems out there. We found this out the hard way because at first we didn't want to build a chunking company. This is really, it's just one of these. I didn't wake up and say I want a chunk. It's more like I
Yeah.
tried to build a legal chatbot,
I
and
can't
then
wait to
I
make.
found this problem. It was literally this. Okay, no one can answer the question. I tested, and then we found what broke it, and that is unsolvable unless you crack the chunking part.
Yeah. So yeah, you really have to ensure that each chunk. Yeah, how do you ensure that the summary, like that it really gets all the information without missing? Like, how do you tell the computer system what
Yeah.
is important, or like, is this a standardized process of like summarizing and chunking
Yeah.
what's relevant? Yeah.
Yeah, now it gets interesting. That's so there's like, obviously, I mean, we weren't the first humans to discover that problem. So it's you find a lot of, okay, how do I chunk, and damn, I have this problem, and so on. So there's like a lot of ways to well, solve this or try. So one would be, obviously, you say, well, first of all, we forgot about that. So let's say you have all these pieces, like, and it's pieces everywhere. You need to chunk, so everyone has some sort of chunks, whatever it's in them. Now then you encode them, put them in an index like full text database, vector database, which basically means, it abstracts the concepts behind it, and then at retrieval, it gets the best. It's like Google for AI. Yeah, you get search results. And now the big question is, so let's say you search for, let's say the home heating split up of, the community you live in. And then we have this magic table. Down here is the actual numbers, and up here is like how we split the home heating. And so the thing is, you might find one of these, and the other is somewhere not too far away. So the easiest trick would be just to say, include all neighbors or half of the document, like greedily, so we might catch it. That actually works, but it obviously puts a lot of dolphins in the net. So you have a lot of bycatch that then, if the question is complex, you have like the bycatch of 5 different search results. Yeah, it's a bit like clicking on every Google result and then clicking on every link that's in it. So it can
Yeah.
escalate quite quickly. So that would be like the normal approach that most people would use. Then you could say, okay, let's have overlap in the chunks. Yeah, OpenAI is super hardcore. I call it the Dodge Ram approach. When you put a document in there in like your custom GPTs, it chunks in 800, like basically 1-page windows with half a page overlap. So if you think of it, it means they save everything twice. So then you get like you get the stuff back, and then you
Interesting.
get
Okay.
like everything twice. It can work, but it's very wasteful, not only in terms of, that consumes a lot of cost, energy, and then in the end emissions, but also, it can get lost. So what we do, and that's the big difference. And
I see.
sorry, and then sorry, please,
Huh.
please interrupt. Go on. Sorry, the latency. Go on.
No, yeah, I guess that's kind of the quick and dirty approach, right? To ensure that you have the overlap, and that
Well, it's what
you
90% do,
will
at
catch
least.
most. Yeah, you will catch most things, but it is very resource intensive, and not to say sloppy, but it just sounds like they kind of brute forced it, as you said, the Dodge
Exactly.
Ram approach. Just read everything
100%.
twice, and then we probably won't miss most of it.
Exactly. Yeah, exactly. And it's super nuts. And even in other approaches, this whole, then just widen the net. Who cares about the bycatch? And the funny thing is, if you think of it, and this was actually how the company was born. So funny story. So there was like 3 years ago we started building, around, it was a bit before ChatGPT came out, and then we wanted to, it was more than 3 years ago. Well, I forget about time. So we wanted to build the system. I mean, I have my first company was a legal tech, basically. I already founded like 23 years ago,
Huh.
and it's still active and kicking. And so we had like all these law firms, and we said, okay, why not build like ChatGPT style thing with RAG, so you don't lose your license when using it, because it doesn't bullshit. And
It doesn't just make
yeah,
stuff up. Yeah.
which actually, I mean, you might have seen it. Like there were lawyers disbarred because they just cited cases that weren't
Yeah,
there
the
and
high
whatnot.
profile it just makes up stuff. Yeah, it just
Exactly. So the
hallucinates the
idea
court
was
case.
like, exactly, and then we said, okay, let's do factual grounding, and to prototype that, like in my second home in Andorra, like the Pyrenees that I just returned from. They have something that, I mean, the US have it a bit. Germany certainly doesn't have it. They have everything legal in one portal. So they have like from the constitution down to the parking regulation in my village, even unpaid speeding tickets and whatnot is all on one platform. Well, format wise is a bit Frankenstein, but you can import it if your scraper is greedy enough. We did that. We indexed 200,000 pages. And then I had my birthday, and it was cool. It was even the former foreign minister. I mean, small country, you get to know people, and we thought like, how cool is it to impress the whole country with our AI solution? That was the most expensive birthday in history for me, and the drinks were free. We spent all on tokens
Heck yeah.
because some people asked the questions, and the questions could only be answered by just casting the net wide and getting all the bycatch. Don't forget, if you put up 1 million tokens into the context window with Anthropic, they advertise we can take 1 million tokens. You know how much this question costs you? $15. It's like if people don't, they always think
Yeah,
like
it's
I
it's
have
not
this
cheap.
car that
Yeah,
can
but they
drive
can do it.
yeah, yeah. See, no, exactly. But you see, it's a bit like I have this car that can drive, 200 miles per hour. Yeah, but if you do that, it really quickly runs out of gas, and that's like what people always
Yeah,
miss. Like
it can make it a few miles.
using the resources actually costs you something, and then also all the other drawbacks. So long story
Yeah.
short, we saw, okay, fuck this. This can't be it. We cannot produce a legal chatbot that costs like $10-20 per question. That won't fly. It's really not the best approach to things. And actually, this didn't change. I mean, this years ago, but the top-notch models still cost between $10 and $20. And you always want the best intelligence for the actual orchestrator and answerer. So yeah, this problem
Yeah,
stays.
that's what I find myself wanting is I'm always going to bias toward, it's like I know the models that are more economical will likely provide a good answer, but it's almost, I don't know if it's human tendency. Like you always want the best
Yeah, I
model,
know what you mean.
and
Yeah,
I
I
guess if you're
totally know
not,
what you mean.
I think in a lot of ways, like I'm insulated from the economics because you have usage limits as a consumer. It's
Yeah,
not as
exactly.
concrete as
You
maybe
don't
if you
see
were
it.
paying for
It's
the
true.
API usage for every
Yes.
prompt. Um, but I think there is a bias toward, I want to use Opus for everything. Opus
Yeah, exactly.
4.7 to tell me,
Yeah, me too.
what I should eat for breakfast today.
Yeah, yeah. I mean that's true, and let's say this
I mean, why
tendency is,
not?
is is real. Yeah, I mean also, I mean if you have 5 friends and you want an opinion, do you ask the most intelligent one or do you ask the intelligent enough one? It's like it's that if there's the option for intelligence, you always go for it. Like it's like no, he's clever enough for that. This is a bit mean, right? But no, but now the thing
Yeah,
is,
it's not
uh,
like, he's good enough at it.
yeah, I mean
Asking
to
all
be
5 of them and then
yeah.
summarizing,
This this is
taking the.
this is by this is by the way what
Oh
I
no.
actually do. Like no, but well, before we get to summarizing quickly on the models. So, well,
Yeah.
first of all, you're right with this. Consumers don't see it, especially not with OpenAI, which is, I mean, it's brilliant. I can use it. Like I don't want to know the tokens I burn through, which is a bit ironic if we're a token saving startup. But there's unmeasured consumer accounts, obviously.
Yeah.
With Claude, you already see it. Like with the now you have to wait until tomorrow, and so you see it creeping in. But let's say for the real stuff, and the real stuff means enterprise high stakes domains, like we're talking about people parsing medical regulations and then comparing it with patient records and finding what the doctor didn't see, and or legal stuff. You have a 5,000 page deal room, find the problem in the deal that leads to the breakup and so on. So you always have this maximum high stakes. A wrong answer costs you maybe 1 million. So, and you better not, blow it up already at data ingestion. And obviously, these questions, they still need the highest intelligence. So interestingly enough, like for our internal like development stuff, like just yesterday, built like some new fine tunings. Well, I still have to read the transcript live because even the most intelligent Opus 4.7 sometimes makes mistakes there. So it's not like we are already there yet. I mean, for the breakfast recipe, okay, yeah, offload it to me, no problem. But for this stuff, you always have to calculate with the best model. And don't forget the Mythos model, like everyone is talking about, is 75 for
Yeah.
1 million
Yeah.
tokens. So $75 per question that you just spent, whatever you found in the library. That is really not the way to go. So you need like to have accurate information. Now comes what you said, Jack. and the whole summary stuff. So there's obviously let's say the other avenue that people are taking besides ours. And honestly, I don't see many other options. The rest would be like just elaborately, cut there, and then put this, but this is like turning knobs. Now, the other option would be to have like auto summarizing of parts of the document. So you could say, and this is, for example, as Google Raptor, this GraphRec is super in. So what they do is they say already at ingestion, abstract the document, summarize the whole section, put a summary marker in everything, or build an ontology, which basically means a map where you say what I found in the document is 5 persons and they are related like this. Sounds super cool. As a data scientist, I love this stuff. Would I use that in a high stakes domain? Never ever. You know why? Because you use AI to actually create your ground truth, so the hallucination already comes in then. So once you have in your
It
summary
could be
that,
introduced in the
my
summarization.
stepdaughter is
Yeah.
actually my mother, we will have a big problem downstream. This is why we say it needs to be verbatim. We cannot change anything in the content. The only thing we can do is detect its structure. And this is now where the fun starts, where our, let's say, secret sauce comes in. I can finally talk about it openly because we got the patent. We got a USPTO patent, not pending anymore. Awarded,
Yay.
everything cool.
Congrats. That's huge.
Thank you. Thanks a lot. No, I'm really proud of it, not because I did my first patent, because I now, when talking to VCs and stuff, it's really a problem. You're like, okay, so how do you do it? Not sure if I want to tell you, but then, then I'm not sure I want to invest in you.
It's really good, I
like,
promise.
yeah, exactly. And then once you spill the
works.
beans, like, cool, they just go to the next guy. But no, so the trick is pretty straightforward. Well, and crazy. Interestingly, until a year ago, AI would have said, no, it doesn't work. Don't forget it. It's a stupid idea. Let's do it another way. And so this is how we detected, oh, we are really outside the training data. It's actual innovation, because AI says it's bonkers. It doesn't make sense. It doesn't work. So what we do is you have a text, and then obviously, well, sometimes you're lucky you have structural markers. You have like the heading 1, like the big title. Then you have other headings and articles, chapters. So you can already say, okay, let's at least, these markers obviously tell us what the structure is. And but then you have like long paragraphs, lists, and whatnot, and they are often too long to say, okay, they won't go over the limit of what you want a chunk to be in size. So what we do is we let AI talk to itself. We literally say, repeat the text verbatim, word by word. Like, what the fuck? Why? Yeah, because AI thinks while talking. This is like the whole next token is predicted by all other tokens before. So when you let it talk to itself, but verbatim, tell me the same text, but do one thing: indent it like it were code. So we make a tree out of a text. We don't change the text at all, but we make a tree out of a text. And yeah, I'm sorry, for me, it's almost, I now have this tree eroticism, because I've always looked like, oh, how beautiful is this tree? But it's literally, imagine you have the information in tree form. You know what you can do then? And this is the simple magic. You have like, POMA is apple in Catalan. So you have the apple down here. And from the apple, you walk up the branch, the other branch, until the root, which is the title, the document's title. And then this path is what we call a chunk set, or this is the unit that we then deliver. So in one of our chunks, you would see in the regulation for the community, in chapter 1, under this heading, there's a third bullet point which says this, and there's the price. So it's still very concise, but it's based on the verbatim original content that is just parsed into a tree by letting an AI talk to itself. It's super gaga if you think of it, but it works so brilliantly.
Yeah. Well, because then you always have accurate
that is
information
amazing,
at the most
because
summarized way. Yeah.
Well, it's the hierarchy of authority with regulation.
Exactly. And this is why,
it's the source of truth.
Yes, 100%. It's the unaltered source of truth, which is also why, the let's say, running this stuff is not as simple as it sounds, like letting AI talk to itself, because then obviously, we parsed, let's say, double taxation agreements, and all of a sudden Australia became Austria and so on. So it's literally, you see stuff like that. It's super funny. So a lot of our business is like fine-tuning the AI. There you have it with fine-tuning. Like, look how I do it. Like, I built a tree out of a document. Now you do it as well. And it gets this abstract knowledge of how to build trees, and not, straying from, the original text, because AI normally, as we said, is not made to replicate the original text. But the nice thing is, if you can make it, if you successfully make it repeat the original text, it has like the whole textual understanding in its mind, so it can directly say, what I find here in a bullet list is obviously deeper in the tree than what I found here. It's super interesting. It's even, for example, when you have exceptions and then reverse exceptions from that exception and stuff, you see it in the tree, like, or you have like Mark Twain, yeah, and then I got a brother. This brother has, a friend, and then he got a mother, and the mother has a husband. So we even put novels in it. It's super funny. And then you can structure the text in a totally different way. And then you have these, what we call cheat sheets. So you get back the search results. Let's say I found these 5 pieces, self-contained. This is like every piece is self-contained. But then obviously you have a lot of duplication. So you don't want to read the title of the document and the headings every time. But since we know where they came from, we just dedupe them. And then we have exactly this. Imagine the perfect librarian. You ask them the question, and he comes back with 5 sheets. And on each sheet is like, in this book, in this chapter, is that important? And in that chapter, that, and in that chapter, that, and the same for 3 other books. Like 4 sheets, thank you. You have all the material you need, 10,000 tokens, you're done. That's pretty cool.
So it's like a map where then if you want further information, you know exactly where to find the larger context.
Oh yes, exactly. Yes, exactly. So we always index it. So what we even do is, well, now we get into what we deliver to people is like, you always see, there we come back to the beginning of the discussion on which page you found the information, which is super funny. And then people even get screenshots of the pages. So what you could do is then, okay, have the context, but then also, like ChatGPT, imagine like sometimes you know it from websites, you paste the stuff you find, but then you also just take a screenshot of some stuff and put it in together, because the visual adapter sometimes works better than the other and the other way around. So exactly, you can even cite the original content visually, which helps, for example, if you have like a convoluted document where on one page, you have this abstract plan and whatnot and so on, and then you find the information in the plan. Oh, by the way, the trick is also we describe every image like for a blind person. So actually we have this,
okay.
when it finds an image, what we do is we let it describe the image exactly like it would be for a blind person, which is a bit different, because it's not like, okay, there's like blue lines and whatnot. That's not what a blind person is interested in. It's like, it's a bus plan, and there's
The
one line.
concepts the image
It's
represents.
Exactly. So there you could say we would hallucinate, true, because we actually let it interpret by AI. But this is exactly why we say, to find the right piece, there's a lot of cues in the description, and the description is now actually pretty good. But you also always get the original image, so you don't have the problem that you have to trust what we saw in the image. And then the text is obviously guardrail, because with text you can measure, is it still the original text, yes or no? Otherwise you impute it.
A lot of these concepts kind of remind me of, in an area of research for, I've been fascinated with is, AI memory, so long-term, because there's working
Yes.
memory, right? And then there's long-term memory, which, when you're working with things beyond the context window, and you touched on the summarization, there obviously are pitfalls to, how do you really condense or establish truths, but this is kind of, it's firing a lot of the same pathways for me as, in a lot of
Absolutely.
ways, this is, you have memory across, especially with legal documents, you may have, the country's law, which is, the
Yeah.
supreme, but that extends
Yes.
across all, you may be looking at a town, but there's a hierarchy that you have to look all the way back up and then come back down. So that's
Yes.
kind of trees of trees, if that makes sense, because there's a
Yeah,
tree
it
of the
makes
country's
absolute
regulation.
sense. It makes absolute sense.
Yeah,
It's
yeah.
funny. It's funny you say it. We just well, it's not approved yet, but I'm hopeful and optimistic. We have a big research project with a public grant coming up, and that's exactly
Oh,
this.
nice.
We call it the tree graph, so that you find like, but we call it, I don't know what the English word is, but in the jungle, you have between the trees, the German word is liane, like these where the apes can go
Swing.
from tree to
Like the
tree.
vines,
Yeah, there
like
you go.
swinging between the
Yeah, exactly.
trees.
Exactly.
Yeah,
So
yeah.
this is the idea that we find
That's
like between the
cool. Okay.
branches there's like interconnections and
There's
this is actually this is where a lot of let's say cross document stuff comes up then, and that's pretty cool because you don't have to alter the
yeah,
document, you don't
yeah.
have to hallucinate, summarize and whatnot. You just give pointers like, hey, why don't you swing to that tree
It's
as well?
connected.
That's
Yeah.
pretty cool. um but
Huh.
yeah, but
Okay.
in terms
Okay.
of yeah, and memory, honestly, it's something that really I'm kind of obsessed with because obviously, I mean, I have like 9 human colleagues, very nice ones, but also 100 agentic ones that are working all the time for me. And if they get their another amnesic stroke, I always grow mad. So yeah, I can. You know what? Why not use this show? There will be over the next days, I think, honestly, maybe even tomorrow, if we're not too lazy to write up the stuff, we will have a big open source publication. We want to gift something to the world, and that is agentic memory. We realized one thing. Yeah, no, it's funny. We realized that, I mean, we do a lot of hard work on ingesting the real world stuff that is out there and chunking that. But if you have stuff that is already produced by machines in a perfect way, so exactly what your Claude Code log, for example, is a markdown that's actually pretty easy to chunk. And we will, make the chunker for this kind of stuff. We will just give out for free. It will be called PrimeCut Nano, and it's part of a package that's called POMA memory, which is unlimited memory for agents, so it never forgets anything. And this in turn is part of Megavibe, which is the tool that we use. It's a Cloud Code on steroids, so to say. And we will open source. Well, they are all already accessible. So if you Google POMA Megavibe, POMA Megavibe GitHub, maybe if you don't find it, you already can download it. You already can have fun with it. But the announcement comes out tomorrow or the day after tomorrow, so you can actually
Cool.
have unlimited agentic memory. That is, yeah, I kept it
Heck
for
yeah.
myself until now, but that's, I like to do it here. So yes, this is the official announcement. Enjoy agentic memory that never runs out.
Awesome. Well, heard it here first.
Well, you heard
Thanks.
the man.
That's
Go and
super.
download when it's available. Yay. Okay.
Yeah, that's
And
exciting.
by the
So
way,
what
memory is
else?
actually reg,
Yeah.
huh? So just quickly,
Oh,
because this is a funny story. A lot of people are working on agentic or on AI memory, and I mean, with some, I mean, I deeply
Yeah.
respect them, but some people go down the, let's say, scientific rabbit hole of replicating brain cells, and wow, cool. But in the end, if you want factual memory, it's
It's
text. It's like it's a bit like, I mean, I still have a lot of memory, funny enough, from the stuff where I did my PhD in, but I would never refer to it just by my brain cells. I would always look up in the original thing. So this whole memory thing I really like. If it's like a big markdown that is very well chunked, it's always better. And so every memory that actually works
yeah. Huh.
is nothing else than a secret rag. So if you use Megavibe, or you take the POMA memory out of it and use it in like somewhere else, is also a package that we published. It will do like secret rag. It's a bit like ChatGPT does it secretly. If you unfold the thinking point, you sometimes see how it's actually asking itself stuff and so on. So all the memory kind of stuff, also like within the thinking processes, there's a lot of rag going on. It's just it's not called this way anymore, because rag was a bit oversold. Like, so many people said, oh yeah, do rag and all your problems are solved. As we said, most expensive birthday ever. This is a bit like the hangover now. So people say rag is dead, but context engineering is the more elaborate word for the 2.0 version of it. That's more than alive, and it's behind every memory exercise you do.
yeah. It's
Gotcha. No, and,
fascinating.
and that's interesting. I just wanted to bring up the point too about, in terms of memory, people seek to emulate structures that already exist. The brain cell.
Exactly.
But you're right in that the functional output of the memory is what people care about, right? It's whether you can recall the information, which is stored in text. So just like a document's page, maybe emulating the brain cell is not the best use
Exactly.
of time. I mean, the brain's great at it. Don't get me wrong; it's
Well,
amazingly
the
efficient.
brain the
But
brain is
who
cool as
says
pointers.
you
It's
know?
this is what I did. The people like, should I use you or graph rag or something? I'm like, no, 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 no. This question is wrong. Like, always have a go factual truth, like a textual factual truth, ground truth, perfectly chunked. and then you have like your perfect library and librarian, and then you can become as brilliant as you want. You can go on, ayahuasca sessions and come back with a revelation and connect some dots. But then in order to produce something meaningful, you have to go to your librarian and ask him for exactly these books. So it's like, why not, you can have a graph, ontologies, but use them as pointers and not as truth. This is like, let's say, let be inspired by the abstract stuff, but then grounded in concrete stuff. Because in the end, especially in
Yeah.
the domains we are in, you don't want to, guess your diabetes. It's not exactly clever. It's like,
It could be there.
That's so funny. It's interesting too because all those AI recorders that every call is now being recorded. I mean, it's never been more important to have like effective and efficient ways to store this information. Because then,
yeah,
if you want to go back to a specific conversation, I mean,
yeah,
even if you take this podcast, right, it's going to be
yeah,
transcribed and all those websites that index podcasts, or whatever.
yeah.
It's like, or if it's personal calls. I know, Sam and I,
It's crazy.
beside.com was, I don't know if I like it or not. I've been using it on my phone for a few months, and it records it forwards the calls and records. That way you build a personal record of every call that you've been on, and it's useful, but then it's also like, wait a second, if I have a question, I need,
it gets much.
it's like, it's like almost too much to like, do we need to be recording
it's
everything?
absolutely crazy. I mean, imagine we're a context engineer company, yeah, and we get like all these transcripts. We're still working on our own context engine, to be honest. And I don't mean the one we sell. I mean like putting our stuff into this.
Yeah,
I mean, we don't want to pollute our own pipeline. And we don't have enough bandwidth for that, and don't want to burn through too many tokens. But we still have this. Slack then has like a lot of messages. I mean, my emails I get more and more under control, and I chunk them well, but like 5% maybe maximum already. But then you have, like you say, all the transcripts. And you know what's funny? You know who runs the biggest rag on earth by far? Google Docs. I mean, imagine it's like it's nothing else than a very big rag. And you see that they have the same problem as us. They didn't have the firepower to run everything through it, because if you ask Gemini what is in this cell, it's like, oh, I cannot help you, but I can explain you what the Google Sheets is like. Yeah, thank you. So you see how it's not connected to the actual documents yet. It's getting better, and I think I'd never bet against Apple or Google, like the oldest rule in life. But so if the moment they get it, then they will vectorize not only the search results, but also the Google documents. But honestly, it could be funny if they then chunk it wrongly. And if you see, like, there was this feature they gave out like some months ago, like super cheap rag, like just upload files. I don't know if you've seen it. You can basically have like with very few lines of code, or even just clicking, like put up your context library in Google. And obviously, I mean, we're always interested in how others do it, and they do exactly the same, like ChatGPT or OpenAI, with the .ram approach. So and this is why it's so cheap. They just ram it in, and then somehow you find some information pieces, and you don't care, because context windows are huge, and so on and so on. But given exactly what you said, Jack, like the ever increasing amount of not data, but data that is increasing. So like the second deviation now escalates. So the speed of the speed that we are increasing the output is like, you can watch how this will crash next week. This is like, you cannot get there anymore. And if you don't have like the structure, people will just give up. So how many of the transcripts did you ever actually, find and read? I mean, for me, the percentage is super low.
Yeah, well, and making everything into like a vector database is only so efficient as the chunks, or like as the summary that you can get back. Because, for example, like if I query like all my transcripts or whatever, it's like, all right, am I even sure it got everything? Like you're kind of at the mercy of whatever, like exactly like retrieval system it's working on. So on the back side of things, yeah, it's a super fascinating.
But then it also depends on how this is why I always say high stakes. But this is why I would never say use for your cooking recipes. If you elaborate, I mean, I'm a hobby chef, so it could be cool. But normally it's not made for easy stuff where there's no problem if you miss something. But if you have like stuff where you you shouldn't miss. Yeah, as if you say find a cheap Mac Mini offer on Google. Okay, you might have missed the cheapest one, but what's the damage? You pay $10 more. But if you miss the one clause in this big contract that in the end will bite you, that's a big thing. And this is why we focus on this. Don't you like no mistake tolerance. And it's interesting in how many domains actually that is the case. It's even in coding. Like if you you see it with all the vulnerabilities that now come up. You've heard of Mythos and so on. So oops, for 27 years someone missed this loophole. It's not cool. Then stuff gets serious. It's not like, I didn't find it because I didn't chunk it so well. Like, sorry, it was a dolphin in the way. This is not exactly the way to approach this stuff. And you will be surprised how many domains actually depend on getting it right.
Yeah. No, absolutely.
Well, and kind of a last, at least, I know we're running up on taking your whole morning or evening up here, but I'm curious what these more, at least powerful from a traditional intelligence standpoint models mean for, obviously starting with a good baseline and chunking your data appropriately and prioritizing what needs to be retrieved is, a large component of the foundation. But how do the increasing capabilities of models like Mythos, how does that impact, does it
Yeah.
enable, with the memory and the
Love the
context
question.
that you
Love the
provide,
question.
is it an exponential type thing?
Let's
Is
say
it kind of a force multiplier in that, we're X squared, or X cubed now?
it's let's divide it into two questions. One is like, okay, how far can this whole stuff go? And as you see, in terms of intelligence, I mean, given that Mythos BSD 27-year-old loophole, intelligence, we are really approaching the post PhD level or even more, and then not a PhD in one area, but like multiple. So that gets super serious. In terms of context window, you see that it's absolutely saturating. So people thought like it's doubling every year or something. And now, you get the million, so they can officially say it's a million and only some want. And then it's fake, to be honest, because, I did RAM experiments. No, really, what it does, it takes like, it processes it in kind of live chunking, and there's corner cutting, and you see uploading a million is so much different from uploading 20 times 50. That's really so you already see that's not the same. So this is kind of saturating a lot, but intelligence is growing better. So this is why it's to answer your second question, it's a multiplicative function. So more intelligence with better context then really gets you somewhere where we go crazy. So imagine you have, this is by the way why Claude works so well in code. The interesting part of code is already a tree. Oh, I think
Yeah.
Sam
I
somehow.
think he just had sometimes things we run into issues recording virtually, but I think he'll probably
He will come
pop back
back.
on. But yeah, no,
He will come
sorry,
back.
continue that thought.
Oh yeah. So the funny thing with code is, and this is why I mean Anthropic is brilliant. I also really like their approach, like not doing like random everything. I mean they're starting it a bit before the IPO, but the whole gag is why they focus on code is not only so Opus makes Opus better, like the Inception loop is, which is, I mean, I don't know if you've seen it. Opus 4.6 is built 100% by 4.5, and now 4.7 is built
It's
100% by 4.6.
it's
And
self-improving.
yeah, but
Yes.
you know why? You know why? You know what the big trick is, and what Anthropic got right. You know, code is already a tree. This is why
Yeah.
code
Yeah.
is you
Yeah.
basically you don't need the same chunking problem, or you don't have the same chunking problem because you can already jump through the tree in code,
It's
which makes
already in
it
a
so much
standard
easier.
hierarchy. Yeah. There's
Exactly. It
no
already
there's
has a
no
hierarchy. This is why it was so
conceptualization.
cool. Exactly. But in
Huh.
terms of everything that is not code yet, you will have the same problem. And then you always, we always are asked, like, what if AI gets better? Then are you obsolete and so on? I always can tell people, for us, it's brilliant because our training and fine tuning gets cheaper. And, we have our own models that then, do the whole, let's say, finding hierarchy stuff. And you're even more dependent on that because the models, as you see, the best models never get cheaper. And then you can yeah, and we ran this benchmark. We have it on the website for people if you're curious. Just scroll down a bit, you see this benchmark. we ran the hardest benchmark from Databricks, this Office QA. It's like almost impossible to answer questions from, treasury bulletins back to 1930s, where it's like literal typewriter scans. So it's the ugliest stuff ever. And in our benchmark, it was funny. The headline is we consume 77% less tokens, but the two other messages is we still use like 340,000 tokens for the hardest of all questions. But if you think of it, if you flip that, it means a normal system would need 1.5 million. So basically miss the 1 million mark that is already too high. So it would, not include everything you need for the right answer. And the rest is made up by hallucinations. But now if you say, okay, let's say we get all this done, and what is the catch then? It's a bit like, well, we save consumption. We reduce your consumption by 80%. So it's a bit like maybe, cars now consume X and then the cars get better. But if you still can reduce this by 80%, you can flip the equation and say you can drive 5 times far,
Yeah.
five times farther. So you could also say we can now answer questions that come from 5 different disciplines instead of just one. The factor stays the same. We are a factor company. Yeah, we're a factor company. So if the rest goes up, cool, we go up with it, or we enable it to go up with the same factor. So I'm very easy on that. I'm a bit concerned though how far this whole thing goes now. Like, imagine like multi-PhD crazy intelligence that then can also ingest all the information of the world. We will have a lot of fun. This would be really interesting.
Yeah, it could be really good or really bad. We'll see. I guess we don't have a choice.
Absolutely. This is what I mean, fun. We don't know.
Well, Alex, can you share what's on the roadmap coming soon to POMA AI?
Yes.
Are you allowed to share anything that's coming shipping next?
Well, as a single founder and CEO, I'm in the nice position that I decide what I'm allowed to do. Well, and then the investors will kill me, but that's a different story. No, I am, and I'm very happy to do. Like as I said, really, we will very soon, like tomorrow, share like the official announcement of the packages. But you find them already at GitHub POMA AI. You find them already in the public repos. So have at it. But yeah, we will have a big product coming up, and that is. We call our chunking engine POMA Prime Cut because we said, it's not chopping, but it's really like making carpaccio out of the text. And now we said, okay, but there's people who don't, who don't want to buy meat, but they want to eat. So we will have POMA Grill, and POMA Grill is like end-to-end retrieval as a service. So you upload your documents, just dump it with us. Literally, you can connect like your S3 or whatnot bucket, or just dump it, upload data, and then you can connect it to ChatGPT, your own systems, whatnot. So we just become your context engine, and then we charge per request. So we will simply say you pay for good context, but you don't pay for ingestion. You don't have to wire anything yourself. You can literally just dump your documents, connect whatever you're using in your environment to the POMA librarian, and then the POMA Grill will serve you the best meat.
That's awesome. That's super cool. This is so POMA
coming in May, hopefully. Yes, POMA-AI.com. Yes.
.com. Okay, awesome. Cool, coming soon. Yeah, POMA. So the grill feature, yeah, it definitely sounds like there's a need.
Let's have a barbecue. Let's do
it. We thought calling it barbecue, but then we realized no. That means you have to bring the meat. So then people think they have to buy 2 products, like first get the prime cut and then put it on the. Yeah, we thought we overthought it maybe, but
no. That's the grill now.
Yes, exactly. So it will be the grill. I thought about deli, but then it's a bit like, come on. If one is prime cut, the other is grill.
Pretty much there, yeah. Well, any final thoughts? Anything we missed today? Any final things you'd like to mention with our audience?
Well, I talked a lot. I'm sorry about that. That's kind of it's a natural habit.
That's the point.
You hit some triggers. Yeah. Well, it's funny. It just came up again. I had this. I don't know if you've seen it. This whole token maxing kind of trend. It's super gaga.
People. Based on how many tokens they consume and like how much. It's just like
it's so brilliantly gaga. It's a bit like, oh cool.
NVIDIA loves it.
I have a logistics company and I give a bonus to the driver that consumed the most fuel. That's exactly the brilliant analogy.
Yeah, it's absurd, but
It's absolutely absurd. It's literally this. Hey, we need more. Like it's this old. Who are you? CEOs. What do you want? AI. What do you want AI for? We don't know. Okay, so how do we
We're
measure
just
it? By
burning. We're
burning
just burning
tokens.
money.
It's brilliant.
I mean, yeah,
So
Nvidia loves this. They want to continue this trend.
Well, the trend is your friend until it ends when the Chinese now switch to the other architecture. But that's that will also be funny. Yeah, no, but my final thought on that, and this is actually when I heard it, it's like, yeah, okay, you can rant about it and whatnot, and Meta, yeah, they have the money for it. No, I have a different learning, and this is like I always tell people: never trust a number that is not divided by another one. There you go.
Fascinating.
That's
Huh.
pretty
Well,
cool,
yeah,
isn't
just
it?
because you can. Just because you
It's
can
like
doesn't mean you should. If you have the money for it, you don't need to be wasteful at the end of the day.
you want bang for the buck. If you have more bucks, buy more bang. Be my guest, brilliant. But
Yeah.
just throw bucks, no.
The
When
money
people
can
tell
go
me, "Oh,
further
we've
more
spent
efficiently.
100 euros on the campaign," I'm like, "Cool. How
Too
many
many
visitors did we get
bucks.
for that?" Like,
Yeah.
never trust a number that's not divided by another one. That's a good life philosophy. It's a bit nerdy one, but it's a good one.
Huh.
That's true. Well, awesome. Well, thank you, Alex, from POMA
Thank
AI.
you.
So
Thank you
much.
so much
Ah,
for this conversation. Yeah, it was a great conversation, and yes, stay tuned to what you guys are building. Really fascinating stuff. So appreciate the conversation, and we're back every Tuesday with new episodes. TechTalkLive.xyz. So yeah.
Absolutely. We'll tune again. Absolutely.
And until then, yeah, we'll have to have you back on. So and stay tuned. Until next week.